The next is nomenclature of alcohols, phenols, and ethers. So you can look into the alcohols, nomenclature of alcohols first. So this is CH3OH. CH3OH in common names, I'll write it as methyl alcohol. That means the alkyl group. Okay, so first write the alkyl group and then put the end alcohol. So alkyl alcohol. So here it is only single carbon is there. So it is methyl alcohol. Okay, it was CH4. CH4 which is called the methane. So we'll substitute one hydrogen with the OH group, and that is how we obtained this CH3OH. So it is called alkyl. So methyl alcohol. This one will be, there are two carbons, so it is ethyl alcohol. So this is the common naming of alcohols. Now the IUPAC naming of alcohols follow these rules. So the first one is parent chain is chosen. So which is the parent chain? We'll choose the longest chain with the OH group. Okay. So once we select the parent chain should contain maximum number of carbon, and also do notice that the OH group should be present in the parent chain. Then only we can call it as the parent chain. It should be the longest chain. At the same time, that should contain OH group. Now the second step is to number the parent chain. So while numbering, the carbon attached to the OH group should get the smallest number, as we discussed in haloalkanes. Okay. Now if there are polyhydric alcohols, or if there are more than one alcoholic group, more than one OH group present, we should use the prefixes di, tri, tetra. If there are two OH group, we should use di. If there are three, we should use tri. If there are four, we should use tetra. Okay. So indicate the position by appropriate number. Okay. If there are this OH groups present more than in one number, we should use these prefixes, and also the position of OH group should be indicated by appropriate number. And for polyhydric, not only for polyhydric, for all alcohols having more than one OH group, that E, we have parent alkane. It may be methane, or ethane. It may be ethane. Take it as ethane. So for such alcohols having more than one OH group, while writing the name of parent alkane, this E should be retained. And then we have to represent the alcohol with the OL. Okay. But for monohydric alcohols means if it is having only single OH group, this E is removed from the name of parent chain and it is substituted by OL. So here we can see CH3, CH2, CH2OH. So it is having only one OH group. So it is a monohydric alcohol. Now we have to choose the parent chain. So this is the only longest chain containing OH group. So this itself is the parent chain. So it is containing 1, 2, 3 carbons. Okay, so we have found the parent chain. The second step is to number this. So you can either number this from 1, 2, 3. But we have the rule, this carbon which is attached to the OH group should get the least number. So this should get the number 1, number 2, number 3. So the parent alkane is propane. Is it propane? But if you are writing the name of IUPAC name of a monohydric alcohol, we should substitute the E. It was propane. You should substitute this E with the oil, propanol, and this position may be indicated propan, put a hyphen, 1, put a hyphen, ol, propan 1-ol. Since it is present at the first carbon, the position may or may not be indicated, no issues for that. Okay, that is propan 1-ol or propanol. The second one is CH3, CH2, CH, CH3. Okay, so we have to find the parent chain. So this one will be the parent chain, this one itself will be the parent chain having the OH group. Now you can number this from here 1 2 3 4 or 1 2 3 4. So if you are numbering this from here 1 2 3, so this carbon to which OH group is attached is getting 3. Now if you number this from here, this side to this side, you will get this at the second carbon. So this should be chosen because while numbering the carbon attached to the OH group should get the least number. So this numbering is chosen. So the parent is 1 2 3 4 carbon. So it is butane, butane, okay, butane. But this is this, okay, this is having only one OH group. So the E should be, it was butane, it should be, this E should be substituted by OL. Okay, so this is butanol and this OH group is present at the second carbon, so butan 2-ol, or you can write it as 2-butanol. It is also correct. 2-butanol, this is also correct. You can write this as 1-propanol. Okay, now this is another example. CH2 OH, CH2, CH2 OH. So this is a alcohol having more than one OH group. Okay, so for such alcohols this E is retained. Okay, if there is only one OH group, E is removed. Okay, so here we have to find the parent chain. So this one will be the parent chain. Okay, so it is having 1, 2 carbons. 1, 2 carbons. If I number from here, it is 1 and 2. If I number from here, it is 1 and 2. So at first carbon there is one OH, at second carbon there is one OH. Similarly, if I take this numbering, at first carbon 1 OH, at second carbon 1 OH. So both are same. So the parent contains 2 carbons. So ethane, ethane at first and second carbons. At first and second carbons we have OH groups. So there are 2 OH groups, so put a diol. Ethane 1,2-diol, or you can write as 1,2 ethane diol. So this is the most used one, ethane 1,2-diol. Okay, now the next example is CH3, CH3 and OH on second and third carbon. So if we number this from here or here, both will be the same. Okay, 2 and 3. At the second and third carbons there will be OH groups, and the parent chain is this one. So it is having 4 carbons. So butane at the second and third carbon, 2, 3, 2 OH groups, 2 OH groups, 2. So diol, butane 2, 3 diol. So this is the naming of alcohols. Now if you are choosing cyclic alcohols means, this is one example. No double bonds here. Okay, no double bonds. It is an alkane, only single bonds are there. If it is having if a cyclic compound is having OH group, such cyclic alcohols are named using prefix cyclo. Okay, prefix cyclo. And consider this carbon to which the OH group is, carbon to which the OH group is connected should be given the number 1, Okay, so consider OH is bonded to carbon 1. So here you can see, here we should give the number 1 to this carbon. So there is 1 2 3 4 5 6 carbons. So hexane. Okay, and since it is having OH group at first carbon, we can use hexane 1-ol. Okay, or simply hexanol, and it is having a cyclic compound, cyclic alkane, so it is cyclohexanol. Now here is another one. We have 1 2 3 4 5, a 5 carbon ring. Okay, and OH on one carbon, CH3 on other carbon. So this OH group, the carbon to which the OH group is connected should get the number 1. So we should number this like 1 2 3 4 5, or else you can number this from 1 2 3 4 5. But if you do this numbering, you'll get the substituents at first and fifth carbon. So first and fifth carbon. Now when we numbered it in this clockwise direction, we get it at first and second carbon. So if you take the lowest sum rule, this will be 3 and this will be 6. So this should be chosen. That is why we have numbered it like this. Okay, now this is the most prior what? Most priority goes to this functional group. Okay, this is alkyl group. So we have studied the priority order of functional group. So this is least prior and this is most prior. So this should be written as the prefix and this should be written as the suffix. So this is 1, 2, 3, 4, 5. Okay, 5 carbons in a ring. So cyclopentane. And at the first carbon there is a OH group. So cyclopentane 1-ol or simply cyclopentanol. Now at the second carbon there is a methyl group attached. At second carbon there is a methyl group attached. So it is at the second carbon there is a methyl group attached. So 2-methyl cyclopentanol. 2-methyl cyclopentanol. Okay. Now we discussed the naming of alcohols. Now the next is phenols. Naming of phenols. So if we have this structure, a benzene ring and a OH group, they are called phenol in common names. Okay, and this phenol is a IUPAC accepted common name. Phenol is a IUPAC accepted common name. So if we have substitution at first and second position, okay, first 1 and 2 position. So 1-2 disubstituted compounds are called ortho, 1-3 are called meta, 1-4 are called para, this one again become 3. So 1-3 are called meta, 1-2 are called ortho. So this is in common naming. So there are some common names and IUPAC names of certain phenols. So here this is the common name is phenol. IUPAC name is also phenol. Okay, an OH on a benzene ring. So if we have a CH3 group on one carbon, for a phenol we have CH3 group on one carbon, priority goes to this, and the carbon to which the OH group is connected should get the lowest number. So it is numbered 1. So 1, 2, 3, 4, 5, 6. At the second carbon there is a methyl group. At the second carbon there is a methyl group and this is phenol. Okay, so 2-methyl phenol. 2-methyl phenol. Here is a difference. Here we have what? This ring means it is what? Benzene ring. Okay, a circle means this is alternate single and double bonds. Here we had no that double bonds. Alternate single and double bonds were not there. Okay, that is the difference. Don't be confused. So this one is 2-methyl phenol and it is in common name it is called orthocresol. If this CH3 is present at the third carbon, it is 3-methyl phenol and it is metacresol. So first and third carbon. Okay, here first and second carbon. 1-2 disubstituted is ortho, 1-3 disubstituted is meta, and the next is OH is present at first carbon, 1 for this carbon, 2, 3, 4. So 1-4 substituted will be paracresol and it is IUPAC name is 4-methyl phenol. Okay. Now for dihydroxy derivatives, that is we have all these have single OH. So dihydroxy means if they are having 2 OH groups, it is called in common name it is called catechol. Okay, that is 1-2 at 1-2 position 2 OH, that is catechol in common naming. In IUPAC name it is called, this is a benzene ring, at a first and second position there are 2 OH groups, so diol, benzene 1,2 diol. If we have these OH groups on the benzene ring at 1 and 3 positions, it is called resorcinol. In IUPAC it is benzene 1,3 diol. Okay, next is at 1 and 4 position, so it is hydroquinone or quinol. Okay, it is IUPAC name is benzene 1,4 diol. So this is about the nomenclature of alcohols and phenols. The next is ethers. So in common namings they are named as. Alkyl group, it may be that ROR means this R may be ROAR. AR means aromatic ring, or both may be aromatic ring. So these are the three possibilities. Alkyl group, okay, two alkyl groups on either sides of oxygen, one alkyl group and one aromatic ring on the either sides of oxygen, two aromatic rings on either sides of the oxygen. Okay, so the common name is alkyl or aryl groups. Alkyl or aryl groups are written as separate words and end with ether. The end of the name should be ended with the ether if different alkyl groups are present. Okay, so for unsymmetric or mixed ethers, we write alkyl ether, alkyl ether, or alkyl aryl ether, or aryl ether if they are different. Okay, if they are mixed. If it is a simple or symmetric ether, use the name as dialkyl ether. Dialkyl ether if both this R group or both this AR group are same, just write dialkyl. So if it is CH3, dimethyl ether. If it is some other ethyl groups, write it as diethyl. If they are different, we should write alkyl groups. Alkyl groups. For such cases, if in the case of unsymmetric, we should follow the alphabetical order. Here you can see different R groups on either sides of this oxygen. So we should write alkyl ether as separate words, gap in between each words. Okay, and we should follow the alphabetical order if it is a unsymmetric ether. So here is methyl and ethyl. So ethyl comes first. So we should write it as ethyl, methyl, ether. Okay, now if they are same, if it is a simple or symmetric ether, just write it as dialkyl ether. So here we have CH3, CH2O, CH2, CH3. Both these R groups are same and they are ethyl. So it is written as diethyl ether. Okay, now the IUPAC naming is for symmetric alkanes, they are written as alkoxyalkane. Okay, that is alk, then write the oxy, then the alkane. Okay, yes. They are written as single word, no gaps in between. Alkoxyalkane. For example, CH3O CH3. If it is simple, we write it as alkoxyalkane. So here it is a simple ether or a symmetric ether. So this is a methyl group. This is also a methyl group. So write it as alk. So that is meth. Okay, alkane means it is similar to methane. Okay, so alk means just remove this ane. So methane, just remove this ane. So that is meth, then oxy, then again write it. So methoxymethane. So methoxymethane for simple ether. For mixed ethers, small alkyl group, then oxy, then large alkyl group. We write it as small oxy largane. So here it is CH3O C2H4. So it is not a simple ether, it is a mixed ether. So we have two different alkyl groups on either sides of this oxygen. So here it is, one is methyl, the other is ethyl. So which is largest? C2H5 means it is having two carbons, so it is the largest one. So the name is small oxy largane. Small alkyl group, oxy, large alkyl group, small oxy largane. So small one, methyl. So methoxyethane. Here it is C2H5O C6H5. So here this one is having 6 carbons. So it is the largest one, this is the smallest one. So this is C2H5 is ethyl. So ethoxybenzene. Okay, and the common name of this one will be, this is what? Unsymmetric ether. So we should use what? Alkyl aryl or alkyl ether, and we should follow the alphabetical order. So here it is ethyl group is there, phenyl group is there. So E comes first. So is not methyl, it is ethyl. Okay, ethyl, phenyl, ethyl, phenyl, ether, ethyl, phenyl, ether. This is the IUPAC name, and ethyl phenyl ether is the common name.